Elon Musk is convinced that the humanoid robot Optimus could become not only Tesla's most valuable product in the future, but perhaps even the most important in the history of technology. The company, which long ago ceased to be just an automaker, has been solidifying its position as a leader in artificial intelligence and cutting-edge robotics. Musk recently gained renewed attention by announcing a special mission involving Optimus. But the truth is that the robot has long since surpassed its role as a simple assistant in industrial settings. The latest updates indicate an impressive leap in the project's capabilities. Internal information reveals that Optimus now operates with a high degree of autonomy, even in extreme situations such as areas affected by natural disasters, epidemics, or hostile environments. This is only possible thanks to state-of-the-art AI, capable of reacting to unpredictable events outside of any prior programming. Furthermore, it features a self-repair system, ensuring continuous operation without the need for human intervention. With advanced sensors, high energy efficiency, and agility, Optimus is ready for increasingly demanding tasks. But this raises an important question. Can we still consider Optimus just an advanced tool? Or is it evolving into something more, perhaps an autonomous agent with true decision-making capabilities? Is there perhaps a larger mission behind this project that hasn't yet been revealed? These are reflections we'll explore in this episode of the channel. Today, the Tesla Bot Gen 3 has gone from being a futuristic idea to a strategic part of the company's growth. That clumsy, barely walkable robot that became a meme on social media has become a respectable machine. This is the result of Tesla's constant effort to achieve near-human performance and offer practical, real-world utility. For a long time, Optimus was the butt of jokes. His movements resembled someone trying to rollerblade for the first time. But that's completely changed. With recent updates, public perception has also shifted. Tesla has returned to doing what it does best, delivering amazing results. What was once just a shaky prototype is now a sophisticated, efficient, and intelligent system. With each new generation, the robot becomes lighter, faster, and more flexible, expanding its presence beyond factories to homes and corporate environments. The next step is already underway. Optimus Gen 3 will be deployed directly on the Cybercab production line at the massive Giga Texas factory. It will take on repetitive and exhausting tasks that would normally require 2 or 3 workers. This change represents a significant advance: increased productivity, lower operating costs, and reduced accidents. In practice, the robot will lift, assemble, and transport parts, speeding up the manufacturing process and transforming traditional assembly processes. In an industry where agility is vital, this advantage could be crucial to competitive success. If you've seen Musk's latest video, you've certainly noticed the difference. Optimus now walks naturally, both in factories and at home. His stiff movements have given way to a fluid walk with firm steps, smoothly moving arms, and an upright posture. According to Milan Kovac, Optimus project leader, the new walking pattern with straighter knees, heel-to-toe strike, and smooth arm movements was trained entirely in simulation using reinforcement learning. Think about it. The robot taught itself to walk, not by hand coding, but through virtual simulations repeated millions of times until it achieved refined performance. This is true artificial intelligence in action, constantly learning, adapting, and evolving. That initial hunched posture was simply a strategy to avoid falls while the balance system was developing. Today, that phase is behind us. Tesla now focuses not only on stability, but also on natural, elegant movement. And the public has noticed. A robot that moves like a human being generates more empathy and is more easily accepted, whether at home, in stores, or in public spaces. Initially, Optimus moved at about 0.98 ms, which was already sufficient for basic tasks. Now the goal is to reach up to 2.32 ms, roughly the average walking speed of an adult. And that changes everything. In robotics, speed also means greater utility. The faster the robot, the more efficient it becomes at keeping up with the pace of human environments. This combination of speed and fluidity is revolutionizing the landscape. And one of the places where this is already being put into practice is the Cybercab assembly line at Giga Texas. Elon Musk confirmed that Optimus will play a central role in this operation. The Austin factory, which already assembles the Model Y and is preparing for the Cybertruck, now also serves as a testing ground for cutting-edge technologies in automation, robotics, and AI. Imagine replacing 2 or 3 employees with a single robot capable of performing repetitive tasks with absolute precision. This is already being tested. Optimus has been evaluated in real factory settings with promising results. It can repeat delicate tasks that require millimeter precision, without interruption, 24 hours a day. In recent tests, the robot learned to identify and separate small automotive parts based on size, function, and required torque, using only its cameras and reinforcement learning algorithms. In 3 days, its accuracy increased by 40%, without adding a single line of code. This kind of advancement reduces errors, improves production rates, and allows human workers to focus on more complex tasks. We are entering a new era, a genuine collaboration between humans and machines, one that goes far beyond traditional automation. The Optimus robot has become Tesla's main bet on the practical application of artificial intelligence. It now uses the same neural network foundation used in the company's autonomous driving system, full self-driving, FSD, allowing it to understand and interact with the physical world in an increasingly refined way. Supported by the Dojo supercomputer, Optimus not only performs tasks but also learns from its surroundings. This continuous learning capability is what truly sets Optimus apart. While other robotics companies face limitations due to a lack of data, Tesla has access to a vast amount of information and even leverages components already used in its electric cars, such as batteries, motors, and drive systems. This vertical integration model reduces costs and allows the robot to be produced for around $20,000. In other words, for the price of a used car, you could have a robot at home capable of washing dishes, folding clothes, or even working on industrial assembly lines. In tests conducted outside Austin, Texas, Optimus prototypes have already demonstrated real domestic skills, carrying shopping bags, vacuuming floors, cleaning the house, making coffee, cooking, and even serving drinks. All of this is possible thanks to reinforcement learning, in which the robot learns from its own mistakes, honing its skills first in virtual simulations before operating in the real world. This ensures that upon commissioning, it arrives with a high level of efficiency and a lower error rate. Tesla has ambitious plans to begin production of 50,000 to 100,000 units as early as next year and reach 500,000 robots in just 3 years. Elon Musk has dubbed this plan the Roman Legion model, 5,000 robots by 2025 and 50,000 the following year. It's not just a bold vision, it's an industrial-scale goal. This technological advancement won't be limited to Tesla's factories. The company plans to apply Optimus to various sectors of the economy. The new generation of the robot represents not only hardware improvements, but also the beginning of a new era marked by more stable balance, natural movement, and real-time decision-making, driven by integration with Dojo. Optimus is currently capable of performing over 1,000 different tasks, from operating industrial equipment to folding t-shirts. And every day, it adapts better to the home environment. The robot is no longer just a machine, but is becoming part of families' daily lives. Imagine an elderly couple being assisted by an Optimus. It can remind them when to take their medication, respond to voice commands, and even inform them of upcoming appointments. In this context, the robot is no longer seen simply as a tool, but as a constant presence, generating bonds, trust, and even affection. This is the emotional factor that begins to emerge, familiarity with the machine. Optimus Gen 3 aims to lead this transformation. From its movement to its rapid learning capabilities, it's the most advanced humanoid robot commercially available. And contrary to popular belief, Tesla isn't rushing to release it to the market. Instead, it has opted to keep it undergoing continuous training within its own factories. This strategic approach allows the robot to be tested in real-world scenarios, gaining practical experience and honing its skills in repetitive and varied tasks. If the tests continue to be successful, Optimus could evolve beyond basic functions like organization and cleaning to take on more complex tasks, such as assembling components in electric vehicles. In the past, rumors surfaced that the robot still needed to be operated remotely, raising doubts about its true autonomy. After all, what's the point of buying a robot if it depends on a human for every action? Having to program everything manually would be frustrating and time-consuming. But there's a misconception here. The remote control doesn't exist due to a lack of capacity. but rather as part of the learning process. Just as we learn by observing, repeating, and correcting, Optimus evolves through practice. Instead of relying on fixed codes, it is trained through examples and experiences, learning to recognize patterns and perform new tasks based on its own interpretations. The learning method adopted by Tesla is what is enabling such rapid advances in Optimus's intelligence. The goal is ambitious: to reach a point where the robot can watch a video of a human activity and, from there, reproduce it on its own, without direct programming. This type of development paves the way for something unprecedented: the large-scale production of truly functional humanoid robots. If Optimus proves useful within Tesla's own factories, there's no reason it shouldn't be adopted in other sectors. Industries across a wide range of sectors may be interested, and those that choose to ignore this innovation risk being left behind. In recent tests, the robot has already demonstrated its ability to climb stairs and walk over uneven terrain. Although its speed isn't yet high, its ability to adapt to different types of terrain indicates it can operate in challenging environments, such as mines, hillsides, and perhaps even caves on Mars. Jokes aside, the most impressive thing is that it doesn't just move. It understands its environment, learns from it, and makes decisions. More than just a versatile robot, Optimus can also identify soil types, search for strategic resources like frozen water, and react to unexpected situations. However, a major challenge remains to be solved. How will it recharge its battery in remote locations? Under normal conditions, the robot simply connects to a charging station on its own. But in extreme scenarios, such as underground tunnels or isolated deserts, the lack of electrical infrastructure poses a major obstacle. Ensuring Optimus continues to function in these hostile environments remains a hurdle to overcome. When the project was first unveiled in 2022, Optimus was still just a rudimentary prototype, with a heavy, unrefined appearance. Back then, it was powered by a 2.3 kWh battery pack made with 2170 cells, the same ones used in previous Tesla models. The revolutionary 4680 battery wasn't ready yet, but that scenario has completely changed. Without much fanfare, Tesla equipped the Optimus with the new 4680 cells, representing a significant technological leap. Although the full official data has not yet been released, the information already available is impressive. This new battery offers 4 times the energy density of the previous version, without increasing the physical size of the assembly. This gives the robot more autonomy while maintaining its lightweight structure. And best of all, production costs have been reduced by 27%, making it more feasible to manufacture millions of Optimus units at an affordable price. The impact of this change is evident. Optimus is now lighter, more agile, and more efficient. Its weight has dropped from 72 kg to approximately 62 kg, and thanks to the new 3 kWh battery, it can operate continuously for up to 12 hours. That is, an entire work shift without needing to be recharged. And most impressively, it doesn't need human assistance to recharge. The robot locates the charging station, positions itself precisely, automatically connects, and when the battery is full, disconnects and resumes operation, all completely autonomously. While an electric car can take 30 to 40 minutes to fully charge, the Optimus, because it has a smaller battery, can reach 100% in about 10 minutes, or even less. Of course, this applies to Earth. On Mars, the challenges would be greater. One possible solution would be to use solar power, since the red planet still receives sunlight, albeit at a lower intensity. The problem is the accumulation of Martian dust on the solar panels, which can drastically reduce their efficiency. In low-light conditions or at night, the rover would likely need to rely on fuel cells or advanced energy storage technologies. Regardless, what we're witnessing is a real transformation. Humanoid robots are leaving technology exhibition centers and becoming part of everyday life. They can already be seen working in factories, assembly lines, logistics centers, and even homes. In the healthcare sector, they're beginning to assist with elderly care. Inside the home, it's no longer a fantasy to imagine a robot cleaning, cooking, or caring for animals. Optimus's ability to locate and connect to a charging station unaided represents a significant milestone in its autonomy. In extreme environments, such as desert operations or mining operations, this capability can mean the difference between operational success and failure. Now imagine a robot that, in addition to performing tasks, learns from its surroundings. As Optimus adapts to different contexts, from ordinary homes to hostile terrain, an inevitable question arises. What will its limits be? With flexible intelligence and the ability to operate without human intervention, could it become the ultimate tool for transforming industries around the world?